Hey, welcome to Dr. Pat TV. So we are looking at functions. Okay, so that mathematical idea, it's all about relationships. And since we're talking about relationships, what's the difference between Friday night dances and the prom? Okay, now Friday night dances, oh, everybody's just dancing with everybody. You don't know who's with who. It's just, for us older people, it's just chaos. I mean, it's just crazy there. But the prom, the prom's nice because the prom is all about relationships. Oh, this is a very special relationship. This would be a one-to-one relationship with each of these couples. And by the way, yeah, that's from my time frame. So I do remember wearing this type of tux. And so the little ruffles and things like that. Oh my gosh, way back when. It's embarrassing. So that's why it's not pictures of me, just of my time. All right, so that's going to be one of the key things about mathematical relationships functions is that there's a pattern to them. We can see how things pair up. In this Friday night dances, we really don't see how anything's paired up. People are pairing up like crazy and dancing with each other. Okay, some real life examples of functions would be your paycheck. For the number of hours you work, you should get a certain amount of pay. So like if one week you worked 50 hours, you get 418, and then if you worked 50 hours the next week, you're expecting 418. If they gave you something different, you'd feel cheated. Hey, when you're looking at your snacks machines and things like this, if I press A2 and I'm up there trying to get my chips, I better not get a bottle of something else or a candy bar. I'm looking for that chips up there. Or if I press A2, I do not get chips and a bottle. Now that would be a bonus for me, but that would mean that the machine is not functioning properly. See, it's not working right. And of course, the other one is if you're texting your friends, you want to make sure that that phone number that you're texting goes to your friend. So there's a relationship between the phone number and your friend. And so that's really key. So you want to make sure that when you're texting your friend that their parents are not looking at that phone, okay? Because otherwise that would not be functioning correctly because that phone number is going to more than one person. Okay, so when we're looking at this, we're also looking at daughters and mothers as another type of relationship. And so we're going to look at the different direction of these relationships. Okay, so if we're starting with here, if we're starting with the daughters here, that's what we're going to call our domain. Domain is what we start with, and range is what we end up with, what we're relating to. So we've got Amy and Anna. They're related to Mrs. Smith. And then we got Jocelyn and Daphne. They're going with Mrs. Sanchez. And then Jenny's with Mrs. Perry. Okay, so in this direction, in the direction that you see the arrows, this is what we will call a function because every person here that we have on the left in our domain, the daughters, is connected with a single mother that way. Okay, so their birth mother. And so that's what we're looking at here. Now, if we went the other direction, if we changed it going from the mothers and then identifying the daughters, this would not be a function because Mrs. Sanchez is connected to two daughters. And if I said Mrs. Sanchez's daughter, we still are kind of confused. Which one do you mean, Jocelyn or Daphne? And so that's why it's important for when we're talking about functions, we start with one and we go only to a single person in this case, this relationship. I start with Anna, I only go to Mrs. Smith, I don't go to Mrs. Sanchez. And so that's the kind of the key thing. It's the direction that matters. Where we start with something and we end up with a single item over and over again. It's consistency that way. Okay, so this is kind of what we're looking at as our definition of a function is that each element of this domain, each person here, each daughter is related to an element in the range, in this case, to a mother. Okay, so that's what we're looking at, the official definition of a function. Okay, and so now we've got just kind of looking at two examples here. I've got a relationship between 4, 5, and 8 with 2, 5, 7, and 9. And so is this an example of a function? We're starting with our input, that's the domain. Our output is the range. So if I'm starting with 4, I'm going only to 7. That's working great. But notice this number 5 here. Because it's got two connections here between 5 starting at 5 going to 2. Starting at 5 going to 9, that 5 is going to two different places. That's really confusing. You see, I should be able to relate these things only one thing. And so this would not be a function. So if we look over here on this other example, with the inputs, each of these inputs have a single arrow going to an item in the output. Yes, this number 1 here in the output has two arrows coming to it, but that's not what we mean by a function. A function means I'm starting at the input over here. Do I go to a single output? And each of these inputs go to only a single number. Yes, the number 1 does get repeated, but that's a repeated output, and that's okay. You just can't have repeated inputs going to two different things. So that's really special that way in terms of the function. It's all about direction. It's about a one-way direction that we're playing with. Okay, and so no function here and a yes for this function here. Okay, so you may have heard this, the vertical line test already. Okay, so if we're looking at a graph, we're going to basically say if something's a function, if the graph is a function, it can only cross one time on the graph. Okay, so you got your little ruler here. So I've got this line right here. Why is this line a function? Well, because every place that we can put this ruler, we only cross one time. So now I've got 3 graphs right here. A first one right here clearly is a function because it's the same example. But now, is this second one a function? Okay, is this second one a function? If we were to put a ruler, a vertical ruler, we would only cross one time. So yes, this second one is a function. However, this third one, not looking good, because if we put a ruler right in the middle here, we would cross 3 different times. And so that would be a yes, yes, no, because we are crossing more than once. It doesn't have to be 3. It could be 5, 6, how many times you want to cross. As long as it's more than once, that makes it no longer a function, because this x value has technically 3 y values connected to it. So it would be really confusing when I say, hey, when x is -1, what's my y value? I have 3 choices, and we don't like choices. We want consistency, always get in the same y value each time. So that's the vertical line test. Let's talk about one more item before we move on to some other things. So we've got a special type of function. This would be the one-to-one. This would be the Prom. This would be where every input has a single output, and an output has a single input. Okay, so I'm looking at 4 different relationships, and I'm asking, who is one-to-one? Okay, this first one on the upper right-hand corner is one-to-one because as clearly A goes to 1, B is to 2, C is to 3, D is to 5. This is a one-to-one relationship here with those. Yes, this is 4 is a little bit left out. It's kind of like me at the prom, but that's okay. We're okay with being left out. We're only talking about the relationship that we're playing with. And so in this particular case right here, this is also a one-to-one function because every item is going to a single item over on the right. So every input has a single output, and every output has a single input. So it doesn't matter if who you're talking about, you know who the date was with the prom. Okay, and on the bottom left-hand corner, this is not a case because this number 6 is connected to 2 different pieces here. That's a Q and R. This is a function, but it is not a one-to-one function. Okay, so because Q goes only to a 6 and R goes only to a 6, so Q and R only have one relationship, but the 6 has double relationships, so that's why it's not a one-to-one, but it is a function itself. And on this last one example that we have here, we have our domain here, and it's looking like every dot here in this domain is connected to only one piece in the range, so it is a function. However, these 2 dots over here are connected to 2 different dots on the other set, the domain there. So this element here, this one dot, is connected to 2 different people. Well, it's still a function, but it is not a one-to-one function. Okay, so that's what we're playing with. Now, how do we know a one-to-one function? You've already, we just covered the vertical line test as a reminder, but to be a one-to-one function, you must also pass the horizontal line test. You see right over here on this one to the right, this is not one-to-one because this horizontal line, this y value, I'm making this number up of 3. This y value is 3 is connected to 2 different x values. And that's why it's not one-to-one, because if I'm standing at this y value, I don't know where to go back to in terms of my x's. Okay, so that's the beginning of functions. Hopefully this is helpful. I'll catch you later.